So like I said, most of you probably aren't as familiar with Kafka as you are with Python, so we'll start with just talking a little bit about Apache Kafka and what it is. So there's a great book if you really want to learn about Kafka called Kafka, the Definitive Guide by Gwen Shapira. It's in its second edition now. A lot of details there. Highly recommend that book. But we don't have time for all that. So we're going to use my version, which is Kafka, the Diminutive Guide, which is a little bit shorter. So first we're going to talk about events, because Kafka at its core is an event streaming system. And so when we talk about an event is something that encompasses a notification and state. So it tells us something that happened, and it tells us information about what happened. So in this case, we have order placed, and we have details about the order. We have a temperature reading, and we have the temperature. Now, we may not need both of those, right? We might have a system that's just checking to make sure the temperature sensors are all online. And if that's the case, then we just know, oh, it was red, it's like a heartbeat. We know it's good. But we also we want to trigger something based on a change in temperature, so we want to have that data as well. So an event encompasses both of those two things, notification and state, and that's really important. So this is an example of what an event might look like in Kafka. Now in Kafka, events are all just bytes. It's all binary in a proprietary format that's very efficient. But when we're serializing and deserializing, it's going to be some type of an object. Usually you'll see it, and the two key components or two main components, a key and a value. The key is usually a simple data type, like a long or a string, and the value is where you're going to have that's your payload. So that's going to be more like an object, like a JSON object or protobuf or something like that. And those events are written to a log, which we call a topic in Kafka, and this is an append-only, immutable log of events. Events are written to starting from the beginning, and you just keep getting added. And you see that number there that represents an offset. And that offset is a number it's auto-incrementing, and it only increases for each partition or each topic log. It never gets reused, and so that offset number stays with that event for its whole life. Now, actually, since Kafka is a distributed system, most topics are made up of multiple partitions, which are multiple logs called partitions, sorry. And this allows us to spread the workload out so that each of these partitions can reside on a different node in the Kafka cluster. The nodes are called brokers. So you have multiple brokers in your cluster, and the partitions will reside on different ones. And this allows us to scale. So events are written to these partitions as log, and right now we're not using a key, we just have a value in here. And so these events are going to be somewhat round robin distributed. Mostly the goal here is to keep the partitions evenly filled up. But as you'll see, we don't have here is any ordering. So you see like our 100 series events are in different partitions. And that makes a difference because when events are consumed or read from this topic, they're going to be read by partition, and we only have ordering guarantees at a partition level. So if order matters, you need to use a key. So when we do have a key, the key is used to determine what partition to write the event to. And so we have this A1 here that there's an algorithm that figures out where that should go, but from then on, every event with that key will end up in that same partition. And this will keep our events in order in the partitions, and that means they're also consumed in order. Now we have guaranteed ordering, which is important if you're working with things like financial transactions. We don't want to have a credit and debit mixed up. Now, this also does mean that we might not have quite as even of distribution. Oops, I went too far. Sorry about that. Oh, no, I have to go through them again. We might not have quite as even a distribution, so it is important to think about what your key is going to be. And this is the same thing with any distributed system that uses partitions or sharding. You can end up with a hot partition if your keys are out of whack. So if you have thousands of customers, but you have 2 customers that make up 98% of your business, then you don't want to use customer ID as a key. All right, so the thing that writes the data or these events to the topic is a producer. The producer is part of a client library. The standard ones that comes with Kafka is written in Java, but there's also a Python library, and there's libraries for Go, Lang, .NET, lots of other languages. But there's a really good one for Python, which we'll be using today. And the producer has the smarts of knowing where to write the event to, which partition it goes to. And it just writes those events one at a time, again, keeps appending at the end. And then the consumer comes along and reads those. The consumer's not really the best name because it doesn't actually consume them. One of the nice things with Kafka topics is they're durable. Data stays in a Kafka topic until we don't want it there anymore, right? We can set a time period, like I think the default 7 days. We can set it for a year, whatever we want. And at that time period, then older things will start getting deleted. Or we can set a size limit. Or we can make it just permanent. We can have permanent retention. So, but the consumer will read the data and do something with it. And then it stays there, and another consumer from a different application can also use it, which we'll see how that comes into play later. So the consumer comes along and reads, and these are completely decoupled. They're independent of each other. They work at their own pace. The consumer keeps track of the partition or the offset that is processed, and periodically it will commit that offset. This is, okay, this is how far I've gotten, and I know I've gotten this one completely done. Then if the consumer goes offline for some reason, the producer keeps on going its merry way. It doesn't care. There is a metric you can watch for that, so you know that something's wrong if you need to intervene, but it won't stop the producer from working. And then when the consumer comes back online, it knows where it left off from that committed offset. It picks up where it left off, and it keeps on going. This is important because it means you never skip any events, and you never lose data. All right, so consumer groups. Consumers run in a consumer group, and consumer groups are a really great tool because they allow us to balance out the workload across these multiple partitions that we have. In this example here, we see I have 4 partitions, and we have 2 instances of our consumer application. This would be the same application, just 2 instances of it running, maybe in Kubernetes or something like that, and they have a group ID that tells them they're part of the same group. And so Kafka will automatically balance the workload across those 2 instances. If we get busy, we want to pick up the pace, we can add 2 more, and now we have 4 instances running, and each of those is getting data from its own partition. That's as far as we can scale with this topic because we only have 4 partitions. You cannot split the data in one partition across multiple consumers. Otherwise, your ordering guarantees are going to be thrown off again. Now we can add a 5th one here. It'll just sit idle, which sometimes we'll do that, and it's a hot standby, so that can be done. And you can also have multiple groups. They're independent of each other. They can read at their own pace. They can read starting at different places. They don't affect each other in any way. Again, the data is durable, and it's independent of the consumers that are reading it. That's consumer groups. Okay, that's it for Kafka. So now back to our event-driven microservices. Well, this is going to be interesting. Really wish the screen worked right. Okay, so this is kind of the current state, and it's kind of a very simplified but pretty common scenario that we'll see with microservices. We'll see we have a client talking to our web server. That's our blue service there, and then it's connecting with this green service over request response based HTTP calls, maybe REST, maybe gRPC, something like that. And then the blue service green service is talking to the red service, the pink service, the gray service. And then sometimes we have maybe an external system that we have to hit as well, right? So this is kind of a common pattern, pretty simple, pretty straightforward. You might have a different variation on it where it's something like this, with an orchestrator that fans out to different services, but still all request response based over HTTP or RPC, something like that. So now this works fine, and it's in use in a lot of places. I've built a lot of systems this way, but I've run into a lot of problems. A lot of our systems, even sometimes before getting to production, they'll end up something more like this, or even worse, right? And you end up with really chatty services. You end up with circular references. It makes it very difficult to maintain or extend your system. And this is where I think event-driven architecture can really help. So let's look at another option. So with a similar type of system, we start off the same way. We're still using request response from the client to our web server, which makes sense. But now our blue service is going to do its work and produce some data to a topic. And then our green service is going to consume the data from that topic and do whatever work it needs to do. And it's going to do that whenever it sees data there, it's going to grab it and use it. It doesn't have to wait for a call. It's completely independent. And blue and green are decoupled. And it's going to write to its own topic when it's done doing its work. And it could be more than one. This is just a simple example. It could be writing to multiple topics depending on the different things that the service might do. Although it's good to have services do one thing if you can. And then the red one consumes that and on and does the whole thing. And in the end, the blue service might consume from that gray topic to complete the loop. Now, with this scenario, these services are all decoupled now. They don't know anything about each other. If the red service goes down, there's no cascading failure. The pink service will just sit there and wait until there's more data in that topic for it to do its work. And when the red service comes back online, the pink service will pick up the data and keep on going. You can have things like alerting and monitoring to see when those things like that happen, but it won't cause failures downstream. And also, this is a little bit more efficient because the binary data in the Kafka protocol is very efficient, and it's a lot faster communication between services than HTTP with text-based messaging. Another thing that's nice is the extensibility. So, there's that extra service we still have. Now, that one's still, in this diagram, is still a request response HTTP connection, because sometimes there's other services that you interact with that don't speak events. And so I wanted to put that in there just to show that it's not either or. These techniques can be mixed and matched as needed when you're building an application. But the other thing is you can extend this. If, say, later on we decide something else needs the data in that green topic, and we want to do something else with that data. Now, we could have just maybe modified the red service to do this new thing that we want to do, but now we have a red service doing more than one thing, which isn't a good idea, and we have to open up that service and do some work when it's already in production. So instead, we can add a whole other service, completely independent of the rest of the application, and consume from that same topic and do whatever we need to do. This allows you to do things like adding on even temporary services onto a production application where you want to do some extra logging or monitoring or some analytics or something like that that isn't part of your main flow and you don't want to interfere with your main application. You can do that just by reading from those same topics. All right, so that's the new scenario. So now how do we get there? So the first thing to do in designing systems like this is define our events. Now, if we're designing a brand new system, which I envy you, that's always a fun place to be, I recommend something called event modeling. There's a video at that link there you can check out that talks about how that's used, but it's basically a system for designing your entire applications using events at the core, from the UI all the way through. So it's really a great technique, and it's a really cool tool that they show in that video as well. So you can check that out. And for existing systems, though, if you already have something in the works, you can still go through your system and find the events. And here's some tips for finding them. Think about what causes a service to start. Is it an API call or something else triggers it to do something? Usually it's an API call. What info does that service need? So what parameters are passed in that call? What action does your service perform? What kind of work is it doing? And then what information results from those actions? Those become your events. I'm sorry, I'm moving away from the microphone. It's just hard to twist and see. So those become the notifications and the clumps of state that will make up your events. Next thing is to define your topics, or how you're going to store these events. One topic per event type is a good way to go. It's a common pattern. Sometimes you might want to do something more like a topic per domain. For example, if you're, say, working with a customer and you want everything that happens with that customer to show up in that same topic, especially so that they can be consumed in the same order, right? So you might do all the different types of events, but they're all related to that same domain, so they go into one topic. Or you can mix and match. Just think that through. It's an important step to go through to think of where the data is going to be. If you have your topic in one topic per event type, then you might end up having to read from multiple topics to do the work you're going to do, which is fine to do, and you can use tools like Faust to do streaming and combine and connect and manipulate your data that way. And then don't forget the schema. Schema is really important. It defines what the event payload is. Especially if you're using multiple event types in a single topic, then you really want to have a schema to differentiate them, but you pretty much always do. Something really simple like the demo I'm going to show in a bit doesn't have one, but normally you're going to want to have that to show what the data in your event represents, so that you can serialize and deserialize it. Now, if you're using schemas like JSON, Avro, or Protobuf, then Confluent has a schema registry, which is a tool that allows you to manage those schemas and evolve them and use them automatically. Okay, schemas will change, so think about compatibility. It's important things to think through when you're doing that. Oh, and one more thing I wanted to make clear. This doesn't mean no databases. A lot of people think it's like events-driven versus databases, and it's really not. What we're talking about is request response versus event-driven. Each of those services in that diagram earlier probably has their own database, right? And I do recommend one database per service if you're doing microservices, if they need one. Maybe they don't need one, but if they do, it'll be there. This isn't between events and databases. Some people think of Kafka versus databases, and there may be some of that in some other domains, but in microservices, that's not really an issue. I like databases. I like that picture. My daughter drew it, so I had to throw it in somewhere. All right, a demo. We're not gonna build this because it's actually built because we don't have much time here, but we're gonna take a look at a random pizza generator written with Python and Kafka. Okay, yeah, so here's my two endpoints. This is for ordering a pizza, or placing an order for pizzas, and we're going to generate these pizzas randomly. So this is going to call out to our pizza service, which I believe is up here. Nope, wrong one. All right. So in our pizza service here, and I'm really sorry, I was expecting to be able to see my screen better than this. To use Kafka in a Python application is really simple. We're going to import a producer and consumer from the Confluent Kafka package. There's other goodies in that package that you could use. There's specific types of producers and consumers. If you're using specific types of schemas, you can use different serializing producers and consumers. But we're just going to use the basic ones for this. And there's some configuration information we need. We just have a config.properties file, which just basically just tells us where's our Kafka cluster at. So it has an endpoint and some credentials for logging in. So nothing interesting to see there, but that's important to have. And then we're going to create our producer here, just using the constructor and passing in that configuration file. And we're calling that our pizza producer. And then we've got a pizza warmer, which is a dictionary to hold our orders of pizzas while they're being cooked. And this completed pizza topic, because we saw that chain that we looked at before, right, a chain of services. The last one's going to write to a final topic, and this just tells us what topic that is, so we can know what to read from to complete the loop. We could hard code that, but I just put it in there because it could change. You never know. We might change the way we make our pizzas. All right, so here's that event or that method that's called when we hit that endpoint. So we're passing an account. We're going to create a new pizza order, giving it that count. We're going to stuff that into our pizza warmer just to hold it there for while we're doing our work. And then we're going to loop through for the number based on the count. We're going to create a new pizza. Sorry, I didn't mean to do that. And then we're going to set the order ID of that pizza order. We're going to set that on the pizza. So now each pizza inside the order has a link there, so we can keep those in sync. And then here's the key part for Kafka. We're going to use our producer to just produce to the topic. We're going to give it the name of the topic. So this pizza object is going to land in the pizza topic. And the key is going to be our order ID. So all of the pizzas for that order are going to make sure they'll be in the same partition. Now, an example, I'm using one partition, but if there were multiple, they would stay in that same partition based on that key. And the value is going to be the pizza written out to JSON. And then when we've done all of them for that order, we're going to flush to make sure they're all written to the topic. And when we do this, this is going to trigger the next application, which I think is over here. So this one is I believe is our sauce service. And so our sauce service has a pizza consumer, which is going to consume from that pizza topic that we just wrote to. And when it sees a new pizza landing there, it's going to be a blank pizza, and it's going to go to work on it. So it's going to find that pizza, and it's going to add sauce to it. And the add sauce function down here calculates some random sauce to put on there, and then calls a sauce producer, which is also defined up above, using the same thing basically, right? You just define it and use the producer constructor to create it using the client config. So we're going to take our sauce producer, and we're going to produce to the pizza with sauce topic using the same key again, and the newly enhanced pizza is going to land in that topic. And then the pattern just repeats, so we don't have to go through all of these. But basically, each of these services is going to have this couplet of a consumer to consume from the topic it's interested in. It's going to do its own work, and then it's going to produce to another topic. All the way till we got to the last one, which is our veggie one. We're going to add our veggies and produce. The veggie producer is going to produce to the pizza with veggies topic. And that's the final one. At that point, we'd have a complete pizza. So we're going to run back here to our main. Whoop, went too far. We're going to run back to our main app and fire this up. The other services are already running. Hopefully, they still are, anyways. So we're going to run that, and then probably do some typos here since I can't see what I'm typing, but. Big crowd here, so maybe we should order like 10 pizzas. No, it'll take too long to run at me. Let's just 5. Oh, how'd that happen? Caps lock, that's how that happened. All right, so that ran off, and it created our order and ran through our topics. And that's our order number, so we can remember it. Listen for that number to be called, and you'll know your pizza's ready. Let's see. Over here, we could pop over real quickly and just take a peek. How are we doing in time? We got update. It's not 10 minutes anymore, I know that. So over here, this is our Kafka cluster on Confluent Cloud, which is, I think, one of the best ways to use Kafka. It's really quick and easy to use. But here we can look and see, just go right to our final topic, our pizza with veggies. We can see here that hopefully our pizzas are sitting in that topic. And there they are. So, so now we should be able, like I said, using that using that order number, we should be able to pull up our pizzas now. And there they are. Those look good. All right, thank you. All right, so I did want to show what we did there for getting the order. So the get order was another endpoint that we had, and that leads to this one here. So for this, what we do now is we'll call this load orders, and that's going to do is fire off a consumer. This is going to be a short-lived consumer we're going to do here because we're only doing it when the endpoint's called. So when we call the thing, we're going to create the consumer right then and there. Now, consumer isn't just created and used. A consumer, you have to create it, and then you subscribe to one or more topics. So you tell it, what topics are you interested in? And we're interested in the completed pizza topic, which is our pizza with veggies. So then once we've subscribed to that topic, now we can pull that topic and just grab any data that's there. So we're just going to loop through, and I put in 60 for now, but we could just, whatever you want to do there, we just pull through that many times and grab any pizzas that are there ready to go. If there's none, we'll just skip that and wait, and then if there's an error, we'll say bummer. And if there's a pizza, then we'll go ahead and we'll add that pizza to our order. And at the end of all that, we'll close the thing. So that's loading the order for us, and then we can just, if we find that everything's good, then we can go ahead and return that as JSON. So in this situation, where the other ones have a consumer that's running all the time, just waiting for another topic to land, because we don't know when it's going to happen, right? And then when it does land, it does its work and then produces to another topic. Well, this one, we have a consumer that we fire off when we need it to get our order. So now with this, we could have also done with threading. We could have maybe had a consumer just running all the time, waiting for a completed pizza and the veggie topic. We could have done it that way as well. But this seems simpler, just to only use it when you need it. You create the consumer then. These are very lightweight objects. You can create them and get rid of them as you need to. So you can see in there we're doing that. We're creating the consumer, we're using it, and then we're being a good citizen and closing it. So it's easy to work with it that way. And we've got 5 minutes left. So that was the demo. And then I was going to, I was going to show you this before. I should have done this earlier. This was what we just built. And there's a GitHub repo if you want to look at the code for that. It's not great. In fact, if you want to look at the code and send me some pointers, I'd really appreciate that. Like I said, I'm a little bit new to Python. I'm loving it, though. After doing Java for so many years, it's like a real breath of fresh air. But that's the application that we just looked at there. Also at that GitHub repo in the README, there's a bunch of other links to other resources that might be helpful to you. But some of them I'm going to give you right here. All right, so this is, we have a site called it's called Confluent Developer, but it's developer.confluent.io, and there's a ton of great resources there on that site. There's video courses, there's quick start guides, there's a Python quick start guide you can check out. All kinds of other good things. There's also this book that you see on the left, Designing Event-Driven Systems. It's a free ebook, not real long, but it's a great read. Really goes into depth about how and why to design event-driven systems. It's language agnostic, but it just goes into the architecture part of it really good. And then there's the GitHub URL again, just in case you missed it from the last slide. And then there's my contact info. If you have any questions at all about this stuff, feel free to reach out to me. Email or Twitter are the best ways to reach me. And if you want to learn more about Kafka, make sure you're here tomorrow for my coworker, Danica Fine. She's going to be doing an even more interesting presentation. Hopefully she won't have the technical snafus that I've had either. So I think that's all I had. If there's any questions now, feel free. Okay, all right, well, thank you very much.